Okay, hello everyone. This session is to review chapter 7, which is arrays and vectors. So I'm gonna type what we need to go over for chapter 7. We need to go over what is an array, how to access array elements. We need to know how to process basically array elements, iterating. We need to know pass arrays to functions. We need to know two-dimensional arrays and vectors. Vectors in brief. So what is an array? An array is a collection of items that are of the same data type and stored in memory continuously, meaning it's a block of memory that have collection of items. Those items must be of the same data type. You cannot have an array of different data types. You can't have one array that has 5 integers and 3 doubles. They have to be all of the same data type. And in memory, they are continuous, meaning if the first item is at address 10, then the next item is at address 11, the following item is at address 12, and so on, so forth. An array allows you to store and work with multiple variables or values of the same data type. Let's do quick coding. So in order to create an array, first I need to specify the data type. Then I'm gonna say this is called my array. I need to give it bracket with the size, and this is it. This is how I declare an array. This here needs to be a constant. It either needs to be a literal like this, or it has to be declared as constant int. And then I can use this constant inside my bracket. If this is not declared as constant, it will not allow me to declare an array. The compiler needs to know at build time, at compilation time, the size of the array. It cannot be flexible. It cannot be variable, meaning I can't ask the user for the size and then create an array based on the size from the user. It has to be at compilation time. So it has to be constant. Then there are several ways to assign items or initialize my array. I can either do it at the declaration level, meaning equals, if it's 5, so I'm going to say it has 10, 20, 30, 40, 50. Notice the fact that it is an integer, I cannot give it something else. I can't say, hey, I want the first one to be character. Now this will work because C++ or Visual Studio will cast it automatically for me. We'll get the ASCII variable for this value and assign the integer value instead of C. So notice here it says 99. You see the pop-up window, 99. So here, this would be 99 variable. If I give it a string, for example, it will not like it. It will say, hey, this is declared an integer, but you are giving me a string. If I don't assign any values to my array, the values are junk. However, if I give it partial values, for example, only the first 3 items are initialized, then the rest are zeros. How do I access elements from my array? Using the bracket and an index or a subscript, meaning if I want to display the second item, I can say cout L my array at position 1 and L. This will display the item at the second position because the first position starts from 0, 1, 2. So 0, 1, 2. These are the positions. These are the indexes. This is at index 0. This is at index 1. This is at index 30. 2, sorry. So if I display at index 1, it will display the value 20. Notice if I display the value at 4, which is the last item, it will display 0 because partially initialized arrays will populate zeros for the rest. If I do not initialize, the values are junk, which is like the default value for an integer in C++. So this is how I access to read. Sorry, to read. I can also access to write. I can say my array at this index equals 100. Now, if I display this at index 4, then it will become 100 because I set it to 100 and then I am displaying it. It's the best way to iterate an array is using the for loop. So for int I equals 0, I less than whatever my size is, and I plus plus. Why this would be the best format or the best method to iterate an array? Because it already has an index. The I is already part of the for loop. So I can use this I as the index. So I can say cout L my array at this I. Since I starts from 0 in this example up to less than size, so it will iterate from 0 all the way to 4. Because at 5, it will break out of the loop. So now if I execute, it will display all the values in that array. Now that it's not initialized, you're going to see that it has junk values. However, I assign a value for the last item. This is for the previous line. So let's remove it just to go so we don't confuse you. So notice now, all are default values for the integer, and then the last one is 100. I can say this is equals to 10, 20, 30, 40, 50. Now, if I iterate, it will display 10, 20, 30, 40, 50 respectively. Next topic. So what is an array done? How do I access array elements? Processing array elements, basically iterating, passing arrays to functions. In order to pass an array to function, similar to any other data type. Now the compiler will treat it as a pointer, and then we're gonna explain what's pointer in chapter 9. But let's take an example. So let's say I have a function called display array, and it will take an array data type. Similar to other data types, in order to pass an integer, for example, I tell it, hey, you receive an integer. If it receives a double, I tell it, hey, you receive a double. So now it receives this data type, which is an int bracket. So I'm going to tell it, you receive an int, and I need to pass the size. So the fact that I told it you receive an array, this function needs to know the size of this array because C++ does not do bounding check on arrays, meaning although that this is declared as size 5, I can access a value out of that bound, meaning let's say at 100. This might break and might not break for different reasons. It depends on this memory address. If this memory address is used by another process, then my program will crash. if this address is available by the operating system, then I will just access it and display whatever value stored in it. So in this case, let's see, am I going to access an address that is not available? Well, it was available and it showed me that this address has this value in it. So the point here is C++ does not make any checkings for the bounds. It will execute the statement. Now, Visual Studio is telling me, hey, watch out, but the program will still execute. Notice, for example, if I say I need to iterate from 0 to less than a huge number. And on each iteration, I need to access my array and L. The first 5 times, the first 5 iterations will display 10, 20, 30, 40, and then I will go out of the bound and start displaying the rest. As soon as I hit an address that is allocated for a different program in my computer, then Visual Studio or my program is gonna stop and is gonna say, hey, you're trying to access a prohibited address, you cannot access this address. So notice, it will start displaying everything up until I reach access violation reading location this. So whatever this address I'm trying to access, this is not allowed for me. Which I is this? It's 466. So all the way from 0 to 465, it just accessed those addresses and displayed the values. Values were, some were zeros, some were junk, other than 0. See? As soon as I accessed an address that is not allowed by my program, then my program crashed. So it doesn't do bounding checking. For this reason, anytime I pass an array to a function, I have to tell it the size. Hey, this array is only this size, because if I go out of this size, the program might crash. And in C++, if you noticed so far, unlike other programming languages like JavaScript, in C++, if one line doesn't execute, has a problem, has a runtime error, then the entire program crashes. For example, in JavaScript, if this function fails, then only this function fails, not the entire program. So a int a array. This bracket has to go here. So now I can take this all the way to here, and I can say I need to iterate all the way to 5, and I can just call the function and give it my array and give it the size. So this will display the first 5 items in my array. So here it is 10, 20, 30, 40, 50. Let's add system. Pause. Here it is. So passing arrays to functions, and let's see how to return items from functions. So let's do um, populate array. Let's say I have a function that populates my array. Let's take 3, for example, 3 values from my screen. So 3 values from the user, and then populate an address, populate an array, and then return it. Return that array to the user. So I'm gonna say, let's call it populate. So I'm gonna say this called populate array, and I'm gonna take no parameters, and here I'm gonna say for loop, let's say 5 times, and then I'm gonna tell the user I need you to see out, enter value number I plus 1, cn into L. Let's declare it as int L my array of size 5 into L my array. This it doesn't like this, so I'm gonna tell it, hey, you are about to return a pointer, because arrays are treated as pointers between functions, and you will get more understanding and on this, but let's do it like that for now. And I'm gonna say I need you to populate this index. Sorry, this is a CN, so I don't need really an end line. So now that I populated this, I'm gonna say return L my array. So let's call it. Let's say I need int an array, some array of size 5 equals to populate array. Then I'm gonna say for loop and display everything. Actually, I have display array, so I'm gonna call display array, and then I'm gonna give it the array, and then I'm gonna give it the size. These two lines can be combined to be display array, populate array, like this. So this statement will return an array, and then it will pass it to display array, and then display array will display it. It doesn't like it because it's expecting to return a pointer, because between functions, arrays are pointers. So I can tell it, hey, this is a pointer. And for this notation or this syntax, you will learn more on it soon. So let's execute. Enter number 1, 10, 20, 30, 40, 50. It didn't like it because of the fact that the pointer died. So let's fix that. So I'm gonna say it's an int equals a new int of size 5. Now it should work. Let me hide this floating thing. Okay, go. 10, 20, 30, 40, 50. So 10, 20, 30, 40, 50. Let's go back and explain exactly what I did. This is declaring a pointer of size 5. So I declared an array of size 5 locally, and then populated it, and then returned that pointer. Now that I returned that pointer, I passed it to display. So display will receive this array and display it. Arrays are treated as pointers between functions. If this is confusing, I can fix it by basically telling, I need you to populate an array of size 5 and then return it. So now I'm iterating based on whatever I receive. So here, I'm gonna say, I need int L my array of size 5. Then I'm gonna say populate array. I'm gonna give it my array and the size. Then populate array, display array will do the same exact thing. So let's go from here. Now, why? What is the difference between this one and the previous one? This one has the array declared locally to main before I pass it to populate array. So by the time I reach display array, this variable did not die. Okay, so go 10, 20, 30, 40, 50, 10, 20, 30, 40, 50. So passing arrays into uh, vectors, passing arrays into functions, sorry. The next thing I need you to learn is two-dimensional arrays. Now, if any of those topics that we just walked through are new for you or confusing, please go ahead and read the chapter. Then, if you're still confused, let me know. Send me questions, send me your questions, what is the issue you're having, and we can go from there. You need to learn about two-dimensional arrays. This array here that we just did is one-dimensional. So it looked under the hood, it looked like this. It was a block of memory. I have a big block of memory. And then part of it was allocated for my array. This was of size 5. 1, 2, 3, 4, 5. Those had the values 10, 20, 30, 40, and 50, respectively. This was at address, let's say 101. Then this makes it 102. This makes it 103, 104, 105, respectively. With two-dimensional array, you want to imagine them as a table. You're gonna, this is one dimension. Two-dimensional arrays, you want to imagine them as a table that has two dimensions. You can iterate on this dimension, or you can iterate at this dimension. You have columns and then rows. Columns for the array and rows for my array depends on the size that you design. Why do we need two-dimensional array? Because everything you see in front of you is two-dimensional array. Any image you see is two-dimensional array of pixels. You have a pixel here, pixel here, pixel, 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 pixel makes it an image. A lot of data are stored as two-dimensional array. Sometimes you have three-dimensional array. Sometimes you have more than three-dimensional array. Anything that is 3D is stored in three-dimensional array. So you're gonna have an array that you can iterate top to bottom, you can iterate left to right, and then you can iterate front to back. So you're gonna have a lot of data in each slot, basically. If you wanna look, if you wanna think of 3D models like CAD files, they belong to a 3D data structure. Inside these 3D, some pixels are transparent, some pixels are solid, some pixels are red, some pixels are blue, and then they will make up the model. Let's say the model is a soldier, 3D. So this 3D model has some pixels that are transparent, and then you have pixels that are solid in a 3D space. Okay, so how do I translate this in the code? In the code, you need to specify a constant integer for, let's call them columns. Equals, for example, 5. Let's do 3. Then you're gonna have int l rows equals 3. So now I can say I need an integer array, which is called like this, and then the rows, number of rows, number of columns. So rows go first, columns go second. So I'm gonna say rows. Let's make it 3 by 2, just so we don't confuse which 3 is for which dimension. So I'm gonna say this one is 2. So rows go here and columns go here. Now I can start populating this using a loop, or I can just initialize it at this level. Just like we saw earlier, you can open curly braces and give it values for the one dimension. In this case, I have 2 dimensions. So values were separated by a comma. So every dimension in this case will be separated by a comma. In this case, rows are 2. So I need to have uh, two items or 2 items that are 3 lengths, that have a length of 3. Meaning, if I go back to my paint, I need this kind of structure. I need 2 rows where every row has this size. So I need 2 items where each item is of size 3. So I go back to the code, I prepare my items, because in this case, every item is an array, right? If I look back to my here I had every item as 1 integer. Now in this case, on the rows level, every item is an array by itself. So the fact that I can populate an array using the curly braces, so now every item is an array. This would be for the first row, this would be for the second row. In my first row, I'm gonna say I have 1, 2, 3. In my second row, I'm gonna say I'm gonna have 10, 20, 30. So now this is my 2-dimensional array. This would be the first row, comma, this would be the second row, close curly braces. How do I iterate this? I need 2 loops. I need nested loops. I need loop that iterates the row, and I need another loop for iterating the columns. So I and J. Now I can say cout my array at this row, at this column. So the first iteration, if I go back to my paint, the outer loop is iterating rows. The inner loop is iterating columns. So at the first iteration, I is 0. So this is 0 and 1. 0, 1, 2. So at the first iteration, I am at I0, column 0. Then I am at I0, column 1, I0, column 2. Then I am at, then the inner loop terminates because I reached the end of my columns, because I'm iterating from 0 to columns. Once the inner loop terminates, then the outer loop will increment. So I becomes 1. And the inner loop will reset, will start over. So I will become at I1, column 0, I1, column 1, I1, column 2. So if I display this, I will see that it will iterate my array. 1, 2, 3, first row, and then 10, 20, 30, second row. Next is knowing vectors. So vector is a data structure that is very similar to an array, but it solves the problems of an array. For example, the first problem a vector solves is having a fixed size. The fact that arrays must have a fixed size at a compilation time makes it a little annoying, right? What if I don't know the size? I don't know. I want to ask the user about a size, so I don't know the size at the compilation level. So this is where vector comes with a solution, where it's flexible in size. You don't have to specify the size at the compilation time. The second thing about vector is that it can change size. It can grow and reduce in size. You can increase the size and decrease the size. Vector is a library provided by the language. So here, when I use integers or arrays or any other data type, I don't have to include anything. But in case I need to use a vector, I have to include the library vector. The way I use a vector is I declare the data type, and vector is a template. Templates you're gonna see templates in chapter 17, but templates work with any data type. So I can have a vector of any data type. In order to create a vector, I need to specify the data type. In this case, I'm gonna specify that I need a vector of the type integer. Then I'm gonna call it my vector. Notice I don't give it a size. I can tell it right now to start adding values to it. Pushback means add at the end of this vector the value 10. At this level, the vector was 0, so now it becomes 10. Then it's gonna add 20 after the 10, 30 after the 20, 40 after the 30, and 50 at the end. Then I can, just like I iterate So notice this is another feature in vector. It provides me with the size. I can query and get the size of my vector. See out L my vector at whatever current I is. Run. Here it is. Another power of my vector is that, so one feature is it can grow. It can even grow at compilation time, at runtime, sorry. So meaning I can iterate, for example, while the user didn't enter, user input didn't enter negative, for example, is not -1. So int L user input equals 0, for example. So while user input is not -1, I need you to ask the user, enter next value. I'm gonna cin this value into some temporary variable, and then I'm gonna say my vector dot pushback, whatever the temp variable is. So go ahead and prepare a placeholder for my temp. So if the user enters -1, I need to stop. So if temp is -1, the user entered -1, I need you to break out of the loop. Pushback. Okay. Then notice at the compilation level, I didn't specify size. At runtime, I am growing in size. Then once the user hits -1, I will just iterate my vector and display everything. So enter next value, 10, 20, 30, 40, 50. Now I'm going to say -1, and it will terminate and display. So it grew at runtime level. I can even resize at runtime level. For example, when I terminate from this, I'm going to say my vector dot resize to 3, for example. So now it will decrease in size. Notice 10, 20, 30, 40, 50, -1. So now it become only 3. So it can grow and shrink in size. There are a lot of powers to my vector, to the vector template library. We're gonna learn more about it, but you need to know vectors because it's very useful. And this would be it for reviewing chapter 7. Please let me know if you have any questions.